Hello everyone and welcome to this wedging series tutorial. On these last few videos, I wanted to do something different and basically run you through like a project-based tutorial. As you can see, what we're gonna recreate is what you see in the screen here. There is a few simulations happening. We have some instances, and I feel like with this is a lot better because you can see how Bifrost can be used for your own projects, right? We There's a few things here. This is just a version. This is my version, I believe, version 5 that I did on the rendering and all that. So this will be a good version to show your supervisor, like a work in progress. If I had more time, I will fix a few things. You can see, there's some sizzling here, like a noise sizzling on the rendering. So I will render this higher res, for example, put a little more samples there. There's a few things that I'm not really happy with the simulation of the grains, for example. Maybe a little bit also the disintegration, which is a custom solver which went around. But again, I think as an overall, I'm quite happy and I know that I can take it further. But with that said, we're gonna start with the custom solver. Basically, we're gonna recreate a custom solver, which is basically driving most of this effect on the disintegration, and that is also driving the smoke simulation, plus also the particle advection that we have here. And also it's affecting the grains, though the grains, as you can see, is not really, is it being affected by the disintegration because it's colliding, but it's not really emitting from there with that said. Then we have some instances. So all this, we have around, I want to say almost 4 million points counting the grains plus the instances and the particles. In total, it's like around 4 million. So it's not like a super high res simulation, but it's a good amount just to show how this is looking to your supervisor, for example, or your client, right? If you're doing this for a client. I feel like you're going to learn quite a bit. There's a few tips and tricks that I'm going to share. Again, we're going to run into create our own custom solver and explain very well that. And beside the background here, these background pieces, which are just assets from Megascan, everything else is done in Bifrost procedurally and running attributes. You're going to learn a lot how to manipulate these properties, attributes, just after we catch the solvers and how we can basically use them for shading or manipulating different, for example, like the emission, right? With that said, I'm pretty excited to run you through this, and let's get started. All right, so this is basically the different graphs. We have 4 graphs: the custom solver, the smoke and particle, the grain solver, and then the post-sim render solver. There are 4 graphs. We're going to start with the custom solver here, recreating our basic infection solver, which is basically driving most of these effects, right? We have a leading edge there that's basically emitting the smoke and the particle. And then when the skull is disintegrating, also is affecting how the grains react to this skull, right? And after that, as I said, the smoke, you can see that smoke and particle solver is not really that big. It's very simple. And then the grain looks complicated, but really is also very, very straightforward. And then we are running the post-sim graph here with a few post kind of like manipulation of different attributes here. And then what I'm doing also just converting this, basically each output I'm converting into a DG node. And this is useful for when you render stuff. You can do like holdouts for different things or creating passes. And this way it's easy to separate here for the render setup as well, which we're gonna talk about it. Everything again is rendering in Arnold, right? Have an Arnold besides the environment, as I was saying before. And as you can see also the interaction on the viewport is very quick. There is no really lag, even though we have like around 4 million points here. But as you can see, we are like showing like the very lightweight points, not the real instances. So we are utilizing the power of the terminals to just to put like all that we see in the viewports on the diagnostics or proxy, but then put in what we need to render on the final. I'll explain all that as well. And we're using obviously the wedging to create different variations for our simulation here, right? And then picking the ones that I like most. For the custom solver, I didn't really use wedging, but for the smoke, grains, and the particles, we use the wedging system as well, just to create variation and see what we like best. So with that said, we're gonna start with as I said, with the custom. We're gonna recreate the infection solver here. And if we go inside, really, it's really very basic and it's very simple, but I feel like it's a good way to get into creating your own custom solvers. I said very art directable. You will see how powerful it is, and just kind of like a friendly, and to get an idea how to create basically a quick solver to manipulate data. All right, let's get started. All right, so I'm gonna close this. Let's open a new graph, create a new graph. Let's delete these guys, and then actually let me hide these guys here, and also I'm gonna hide the environment. I'm gonna have the light environment. Let's go 6, and let's put the grid back to the perspective, home, and now we're back. Cool. I'm gonna create a plane, create mesh plane here. Let me go back to the first frame here. And let's create a terminal. I'm gonna make it a little bit bigger, so let's do 20. And then definitely one more points, like around 300. That should be enough. Let me hide now and check this out. And that looks more than good for this demo. Great. I'm gonna create a point. So I'm gonna say construct point. And then I'm gonna right click in the point position and say find in, and then create value, and that basically creates a point right at the origin. And you can create more points like this, by the way. You just right click, create value, and then move them around. For now, I'm just gonna create one point, and I'll do a point scope here so we can see it, because you won't be able to see it. I mean, you can kind of see it, but it's very small. It's very tiny there. And probably in the recording it's not going to show up, so I'm just going to put a point scope, and now you really can see it. Cool. So what I want to do is create basically 2 attributes, one per stream or tree, right? One for the grid and one for the point. So I'm going to say set geoproperty here. So when I create an attribute or property, and I'm going to call this mask. You can call it whatever you want. This is completely I leave it up to you. You can call it as you wish, infected, non infected, infection, food. There's so many names for this, but I'm gonna just call it mask. And I'm gonna initialize this attribute with 0. I'm gonna copy this, paste, and for the point, I want to initialize this to 1. So if I do an assign diagnostic material now into here, and I just change this type, remember that we have this hat, and that means that you can hook up different kind of data types. You can also right click and change. Sometimes they give you a few data type that you can change here, or you can just set it yourself. So I'm gonna say set value type, and now I'm gonna click a string because I want to type. And if I do mask, this won't show up. I mean, it won't tell me much because it's 0, but if I change this to 1, now it's going to be all white, right? But 1, 0. We have 1 here. So if I do this, now the point, I mean, it's just a point, so you won't be able to see it. But what I want to do is transfer basically this property from the points into the grid, right? This value basically, right? The mask attribute here. So for that, I'm going to use the transfer property. And this transfer property is a node that I created myself that you will have it. But basically, it's nothing else more than just some get closest location or get closest point, depending what it is, right? Depending what we feed the input. So if it's a strand or a mesh, it's going to use the closest location. If it's a point, it's going to use the closest point. That's it. And then there's a few for each, and then a few post process that I do here as well. Anyhow, you don't need to know. It's just basically transferring a property into like one from one place into the other three. The target is going to be my grid, and the source is going to be my point. And what I want to transfer, basically, I have the mask attribute. I want to transfer also the mask. And as soon as I do that, if I can type, it's going to go all white because we don't have a cutoff distance. And as soon as I do this now, as you can see, let me hide the point here. We have a little white spot where exactly the point is. And if I move this point around, that is going to follow. Hopefully now that makes sense. And the cool thing is that we can play with this cutoff distance, right? So we can grow it or make it smaller. I have a little option here, which is the post process that I can blur this. So if I do mask again, just so I can blur this, you can see that that is blurring the attribute as well. And then you have a little, a few options here for how much you want to blur this guy. All right. Anyhow, I'm not gonna blur it. I just want to have it like this. But what I want to do is basically grab this attribute transfer, right? Or I'm sorry, transfer property here and put it in a solver. That's the plan. So we can actually obviously kind of start growing this, right? Obviously, you can key this, right? This parameter here, and you don't have to run it. But when you do stuff, sometimes in Solver, it can give you more organic look, and then also you will see the difference very obvious as well. So let's do that, and then let's talk about solvers in Bifrost. A simple, so there is a bunch of solvers. Obviously, we have, if I go into the node library here, and you go into the simulation part of what Bifrost offer is here, we have the aero solver, we have the particle solver, we have the npm solver, and we have the boss solver, right? But there is also less complicated, and one of those is called simulation example. And this, if you, I'm clicking here and dragging and dropping here, you can do that from the node library. If you, for example, it's good to know, use this if you are looking for a node. For example, I don't know, if you're looking at, okay, I want to save something that maybe said fine, and you can look, and it's going to give you all the words that are looking for this. So this is good actually for learning or to look for a node that you might not know, because obviously there's a bunch of nodes and then plus the compounds from other people too, you know. So it's actually the node library is a good way to start, because when you do find here, it also is going to give you the leads of all the nodes, but it's a little more difficult to see exactly where they come from, if they are Bifrost or not. And here it's a little bit easier to do that, right? Because telling you, okay, that is from a third-party compound, and then also the Bifrost ones and stuff like that. Anyhow, all right. So let's talk about solvers. So the simulation example is a simple solver, basically. And if you go to the info tab, you can read about it. And they explain you what these things do, basically. We have a starting frame, we have a starting data, and a state. And as you can see, this guy has kind of like a little circle or like a loop, right? This means that basically you fit something into the starting data, and that whatever you do inside, that's going to get out, it's going to go out, and it's going to read that back again into the state, depending how many times you run this solver, right, on your timeline. It's going to be, and you can add, you can subtract, you can multiply, you can do multiple things inside a solver. If we would go inside, the Bifrost team provide you with an example here, or like a simple gravity example. As you can see, it's not edible, it's reference. So if you need to work, and now I cannot really do anything inside here. So you need to make it edible, and for that you right click in a node and you say make edible. And most of the nodes are kind of like they're locked. When you see this, right, the no edible, but you can go again and then just make them edible. So you can go inside and see how the nodes are built, even the ones from Bifrost. Some of them are black box, but most are, we'll say like 95% of the nodes are like an open book, and you can see and learn how the nodes are built, which is great, because if something is not working, you can go inside and fix it yourself or add more functionality, for example. All right, so simulation example. As I said, you can play with this on your own time, just connect them where they say, and the reset or the simulation, and then you can see what this do, but it's just basically a graphic example. I'm gonna go and delete all this. And as you can see, we have a reset here, and basically this is just a compound, an empty compound that you can put your own nodes inside just to keep everything tidy and organized. That is the same than doing a control G, right? When you create like a compound here and you go inside and you can hook up different data. I'm gonna delete this, I'm gonna delete that, delete this as well. I'm gonna do everything on the top level at this moment. I'm gonna change though, the only thing I'm gonna do is just rename the path. So I'm gonna say starting data, because that's gonna be my starting data. And I'm gonna say sim. And as you can see, the starting data goes into the reset case, and that means that whenever you go back, depending which start frame you have, in this case, I have a 1010, so let's do that right away. So that means that it's gonna reset whatever attributes you are setting, right? Or properties, right? In this data. So if you're setting some attributes here and you go back, this is running, right? And then you go back to frame 1010, that's gonna reset. Then you have the sim that is going to the next step case, right? And this is the sim basically that is gonna be reading. So then you have the state, which is going out and is going into the previous case and next steps case. So you're gonna do something that's gonna be read by the solver. Then it's gonna go back to the previous case and then also to the sim. You're gonna, whatever you're gonna do, you usually don't touch this previous case unless you wanna grab something from there. But whatever you're gonna do is gonna be here in the sim. And then you're gonna be basically replacing this with your own nodes and into the next case, right? The manage simulation state, you don't really have to touch any of this. This is just how, it's just to manage the solver itself. You can go inside obviously and check it out and see how it's built, but you don't have to really touch this at all. All right, so let's talk about, so this is expecting a float just because I can tell from the color. But as you can see, it has like the little hat. That means there's an auto port that you can hook up any kind of data type here. Now this is complaining because it's expecting again a float as a default. And the easiest way to fix this is just basically hooking up the same data into the state. And now the error or the warning basically goes away and actually now is outputting the same. This is an object, right? And that's what we want. And it's outputting an object and that's going to be read by the state. Boom, boom, back and forth. Another way that you can change this is just actually you do it manually. So you right click and just say the value type, or you can do it right through here or sometimes through the value type right here. So if I do this and I say, okay, I want to specifically tell the solver this is just going to be an object, then you do that. And as you can see now, the hat went away. So if I disconnect this, it's going to give you a warning because it's specific, expecting now an object, right? Again, the easiest is going to be this. So now, for example, let's create a value here. Now, if I try to feed a float, it's going to complain, but if I feed that there, actually, let me come back because this should be an auto in reality. Auto. It's better to leave it in auto so you don't get that error warning there. But now I can change the data type to like whatever. So if I want an integer back, it's going to be now integer. Again, you need to be connected, right? So now with integer, you can change to this if you want to go work in the solver doing some kind of Boolean operation, integer, or, a vector, whatever, you can do all that kind of stuff. Cool. So let's do this. I'm going to feed that. I think there is enough of that. So I'm going to feed in that. And if you need to get data from a different tree, right? What you do is just connect it into this plus. And now I'm going to call this in instead of out because really it's in. It's going inside the solver here. And now we have that. We have our starting data. It's going to get in the same. Let me just hook it up here. Nothing's going to happen here, obviously. And actually, let me cut this. Or actually, I've cut it. And let me hook up this. That's warning, errors. Now everything's black because we don't have anything, right? So I'm going to go here, paste the transfer properties. And our starting data again is the input. So I'm going to hook up the same into the target. And then the source is going to come from our in geometry, our second input or or whatever, right? You can do this for multiple. There is not really a limit, so you can start. I mean, obviously this doesn't make sense, but if you have other kind of data here and you want to hook it up and you can read data from the solver, you can do that as well. So now this is gonna come place. I'm just gonna delete this, all these ports because it is empty. Delete. All right. So we have the mask. We're transferring the mask. And what I want to do basically is get this attribute here. So I'm going to say get geo property now. And the property that we want is the mask. And also I want to get the property basically from the previous case, or the same, right? Again, this is the first frame, remember, right? So I'm reading this at the beginning. So I'm reading this. And what I want to do here, let me just go a little bit smaller. 0.5 should be more than enough for this. And what I want to do is get the max value between these two properties. So let's say max. We want to get the max value from the starting data and from the data that comes through the previous frame. And this max value, we're going to set again, we're going to set this mask attribute. But now, instead of setting into the starting data, we're going to go and set it into the next case, into the solver. So I'm going to say this, connect it right here, and now this is going to go out into the next step. This is what I was explaining at the beginning. And the property again of the attribute is going to be the mask attribute. And really to keep it more procedural instead of, I mean, if you're not going to change this, it's fine to leave it like this. So it's like less crossing of wires here. But sometimes you want to create a value and then just hook up everything here, right? That way, if you need to change the name for whatever reason, you can just change it in one place instead of changing, go to each node and try to find that, right? Obviously, you need to remember to do this. So now, again, nothing's going to happen. If I press play, you see that when on the first frame, after the first frame. And you saw that in 1011 is when we get in the max. Boom. After I run the first frame. If for whatever, and that happening because the reset case is reading from here and not from the transfer properties. So if you want to see that value already on the first frame, you go here and you put the reset case so it reads this value instead. And if I press play, nothing, and again, nothing's going to happen. This is just transferring the attribute. That's it. So basically, we're doing the same thing that we're doing outside, but now we're doing it in a solver. And the cool thing about doing it here is that now we can make this grow. We can make it grow. And the way that you can make grow this, there's a few ways, but the easiest way is just to kind of smooth this, right? Basically what we're doing here, but instead of doing it in the starting data, you want to do it right here. Actually right here after we setting, right, into the output. And for that, we can use the smooth geo property. And this node is from the Maximate library. So if I go into the node library here and you look for MGCG, and I highly recommend getting this library. There is some great nodes. It's great. So I will highly recommend getting this. So I'm getting this from here. Again, this is going to be all included in the file anyway. So we're going to use this guy to kind of grow this a little bit. So I'm going to hook up the input or the output of the property here, and then that's going to go into the next step case. And the property is going to be expecting a float already, and we have float values or float attributes here or data, and we're going to hook up the name, the property. So there you go. So now it's reading the mask. By default, it's basically smoothing this by 10 times on each time step. So if I press play now, you can see that it's kind of growing, right? Little by little, it's growing. But if you want to give it a key, and you can keep running this longer and longer, and eventually it's gonna grow. But to give it a little bit more like a kick, so it kind of grows faster, and you can control that speed, there is what we can do here is basically create a little contrast, right? I'm gonna just move this out of the way. That is the thing about, hopefully this gets solved because sometimes the wires get all over the place and they can become a little bit messy. I'm not gonna deny that. But what we can create a little, as I was saying, a little contrast here in this value before we setting the attribute, right? So for that, I'm going to create a ramp, evaluate F curve here. We're going to say, when I go here, this by default is a Bezier. I'm going to just change this to a constant here. And then I'm just going to add a point here and then just get it up a little bit. So that's creating some kind of a contrast, right? So now if I press play, shut up, there you go. So now we have a growing attribute right here. So that is working, right? So we're seeing this, and if we look at the data, right here, we can also just look at the data, by the way, mask. You can see that that's going to start growing and then start basically infecting these points. You can see that it goes like up to 1 for now. Cool. So, and when obviously we can control how fast we want to grow this. We also can control by the smoothness here. So if I put less, now this is going to be a little bit slower, right? And also kind of change a little bit of the shape as well, you saw there. You can also obviously promote this and control. So it kind of start slow and then start becoming, when we get there, it's going to start controlling, it's going to start getting faster and faster. But you can control that way the speed. So that actually is growing in an expected way because we're smoothing this point basically on each time step. So it's growing in an unexpected way, right? Obviously, we can change this to any place in the grid. And now this is going to grow as well, right? From there on. Now that's a little bit too slow, so let me go inside. Let me just give it a little more like something like that. Okay, it's just a them. There you go. All right. I mean, this is good and it's dandy and it's good, but it's a little bit boring, right? Just a blob basically growing with any kind of like resistance or noise or anything like that. So we want to add that. Before we do that, let me actually give you a little tip here. I mean, it's just something that it's not a tip, but in case. So remember, my solver is starting at 1010. If let's say that you frame range start at 101, you see that now my geometry disappear because that's going to start reading at 1010. As soon as I go to 1010, now this is when the geometry shows up. Obviously, if I go back to 0101, it's going to be fine. But let's say for whatever reason you want this growing to start later in time. I mean, there's two ways to fix this. So we can merge, right, the geometry outside the solver and then just hook up the merge here. So we could do this and then come back and then do this, right? And that is fine. However, the solver have this other input here, which is not used, and it says before start frame case. So in case that you want to see the geometry, right, you can hook up the starting data into there. So this is actually a much better way to do it, right? Because now there is there's still the grow, right? It's going to start 1010. You can see that before even 1, 2, I'm just stepping one by one, and then we go by 10 by 10. When we get to 1010 is when the solver start working. So this is a good little thing to have actually, if you need that. Let me go back to 1010. I don't want to wait 10 frames. As I was saying, this is kind of a little bit boring. And by the way, here, as I was saying before, you can create another point here, right? Leave it there. And now we have 2 points growing at the same time. So you can hook up different points or even geometry, right? I mean, if that's to be points, I can just put, I don't know, a sphere, move it around here, bring it into, right? We can just, let's say that I want to use the sphere here, and now it's going from there. So you have full control basically over where you want to use this, or kind of like work, right? All right, cool. So let's make it a little bit less boring. And the cool thing about this smooth geo property, as you can see, is that we have a way port here. And we can use this port in order to kind of create some kind of resistance or kind of like, so it's not as smooth, right? So again, auto port. So I'm going to change this onto a string because I want to type, and I'm going to call this just wait. I'm going to copy that. Again, this is not going to do anything because we don't have any attribute that is named like this. And what I'm going to do is go outside here, go into the plane, and create a quick noise. So I'm going to say fractal noise fill, and then we're just going to sample it. Fractal noise fill. I'm going to set a new attribute here, set geoproperty. And this property now is going to be called weight. And I don't need to set up this here because again, this is the starting data. We're just transferring, remember, this one value into basically this 3, right? So the weight can be here. You don't have to copy and paste it right here. And then I'm gonna just real quick sample this, sample. I could bring also the one that I have and get the positions here. So get point position, sample, and then just set up. Cool. And just to look, we can just change this now to weight and see what it does. And there you go. Now we're looking at the weight. I'm gonna play with this a little bit, just make it a little bit bigger, something like that. And as you can see, this noise goes it's -1 to 1, I believe. Yes, that's the range. I'm gonna just leave it like this and then run this. Remember that we have the weight already into the weight property here. And let's see what this does just by leave it, and then let's change it to mask so we can see the mask. If I press play now that looks a lot better, right? As you can see, this is getting a lot more organic and the grow is kind of cool. Now we have an issue, right? The issue is that and let me actually make it very, very copy and paste. And let me call the weight here. Oops. Weight. I'm gonna put this into the proxy. So you can see that this is basically matching 1-to-1. You can see that the Y where the solver is growing is where we have even if it's a little value, it's gonna start growing. Other than that, it's 0 or -1, right? You can see how that's following the noise exactly. So in order for, obviously, if it's a growth solver, you might want this or not, but you want basically the solver to run everywhere. So what we can do here is basically just clamp, right? A quick clamp is going to fix this, or just an F curve or whatever. But I'm going to say 1, and then the minimum, instead of being 0 or -1, I'm going to say, give me a little bit something here. So like even the smaller value is going to make it. So if I do this now, you can see that now, you see how that changed? It's not completely dark. And if we look at the solver now we're talking. And you can see we're still keeping that kind of organic, cool looking thing, how this is kind of like growing, right? There you go. So that now is looking pretty neat, right? Or actually a little bit better. And you still have full control because now you can play with the noise here too. For example, it can be anything. Obviously, I'm playing with the noise because it's easier. But you can play with whatever you want here, right? Let me make it a little bit faster too. So I'm gonna just increase the smooth, and that should make it a little bit faster as well. But now this is looking a way nicer. It's kind of like an ink drawing away, right? You can see that it's a lot faster also. You can also obviously change this guy a little bit closer, and that's also gonna make it grow faster. So that's pretty cool. But let's say also, for example, if you have something in your geometry that you don't want to infect at all, what you can do, for example, is create some kind of like a dark spot, right? Because this is just values. So I'm gonna use a fall off here, and this is from our friend Val, right? And real quick, I'm just gonna say SRT matrix. I'm gonna turn off the noise here. This is just a feel, but we can. And what I'm gonna do here is just basically grab this. just making a space. I'm gonna do the same sample for the same position, but now I'm gonna sample this other value here and then basically multiply this. So if I grab this and then multiply that, this is by default is gonna be at 0, 0. I'm gonna scale it a little bit. You can also bring a locator, by the way, and move it. In this case, I'm just creating this. Let's say that I don't want anything to grow there. Let's leave it like that. I can't quite remember if this by default. Wait, yeah, okay, so I need to reverse that. You can see that it's just acting there. So I'm gonna reverse this guy here. And what I need to do is just operate an F curve field because we're working with field data here. And the only thing that I'm going to do is just switch this back. So now we have that dark spot right there. Pretty obvious to see, hopefully. So now if I run the solver, it's going to basically avoid that area. So now again, this gives you a little more artistic control, art directable, how you want, whatever you want to call it, but basically you are avoiding that complete area. For whatever reason you want to do that, you have the option to do the same here. So basically that's it. I mean, this is what I did. I mean, now that when we come back to the custom solver, it's basically this. And then I add some functionality that what you see here. And then what I did to create basically an edge from here, after the solver, the only thing that I did is create, I grabbed the attribute here, right? So I said, get your property here. And actually, I'll explain this and then I create a mask. I smooth this. I create an S-curve again, ramp. And then grab that attribute, right? Because we know that it's from 0 to 1. And I just created, basically, I grabbed this preset here, but instead of going from -1 to 1, I say grab the middle point. I change this to 0.5. Grab the -1, and then I say 0. And if I hook up this now, and I just said set geo property here again. So we look at this, set geo property. Just real quick, mask. We look at the mask now. You will see that what we're gonna get here is kind of this edge. Pretty cool, right? And you can obviously control this to make it a little bit, if you want to make it a little bit not as thin, you know, right? So you have full control here. You can play with the ramp there just to make it less. If you want to make it also even more and more softer, you can also again use our good smooth geo property here before we fit that, and then just say mask, and you can see now that we have a bigger edge. And what I did with this, I'll explain this after when we go back. But basically that was it. So I run the solver, the full solver without this in a different tree. I grab that for the disintegration, and then I run this basically for my emitter of the different, for the smoke solver and the particle solver. So from one solver, I grab two things, and I use those two, just changing a few things with attributes. And that is the power really of using stuff with attributes, because they give you a lot of flexibility. And now again, you know, you can change this plane for whatever other object, and all this for the most part should just run. Obviously beside, I mean, the starting point you might have to change, but you can, and then maybe wherever you wanna basically have the avoid object, right? So it doesn't grow there, you might have to change that. But for the most part, everything else is working. I mean, everything inside here, right, works. This solver just works. There's nothing else. You can add more now functionality to it, but the solver is working. And with that said, I feel like this is a pretty good overview. Hopefully that you like this one, and let's go back now to the custom solvers. Cheers.